Let's look at how we can use a sketch to help us find the region which obeys all three of these inequalities. We're going to start off by sketching all three of these. We'll start off by just sketching them as lines, and then we'll consider which side of the line we wish to be on when we actually look at combining all of these inequalities. Okay? So, for this first line, in this form, it's usually easiest to sketch by finding your x and y intercept. We'll have an x-intercept of 3 and a y-intercept of -4. Notice that I've represented that with a dotted line as it is a strict inequality. I can go up to 12, but I cannot be exactly equal to 12. So let's label our x and y intercepts, -4 and 3. And you may find it helpful to just label this line so that you don't forget once you've done the rest of the question. Next one, x-intercept of 6, y-intercept of 4. So let's just draw that. Some line like this. Bear with me 1 second, I'm just going to get a better pen. There we go. I've improved that line, just needed to get a pen with a bit more ink. Okay, so let's just label our points again. 6 and 4. Notice that I'm now using a solid line to represent the fact that it can equal 12. So dotted lines for strict inequalities, solid lines when you can equal the value. Okay, now we need to do our parabola. So let's just factorise this to make it easier to sketch. So this one also needs to pass through 3 on the x-axis, but also -4. It should have a y-intercept of -12. Please just make sure that you do have the turning point in this quadrant. Remember, parabolas are symmetrical, but this one has been translated slightly so that it's not symmetrical about the y-axis anymore. So let's just sketch that. It should look something like this. So passing through 3 as well, and -4. Okay, I've missed it ever so slightly there, so I'm just going to make sure they do in fact go through exactly the same point, because it's important to represent that. Okay, so worst parabola ever. There we go. Okay then, now we can start considering which side of each line I want to be on. Looking at the parabola first, I wish to be in the region above the parabola. Remember, y equals this quadratic is that line, that curve, sorry. So therefore, if I want y values which are greater, any value above the line will satisfy it. So I wish to be above this parabola, this region here. What about the red line? Well, that's saying that my x value must be less than 12, or 2x must be less than 12, so my lower x values will be to the left of this line. I want to be looking this way. Alternatively, if you want to consider the y, it's also saying the y values must be less than, so I would want to be below the line. If you look at that though, they're both describing this region. Okay, so far I can tell that it's this bit here. I'm just not sure which side of this blue line I will need to shade. So let's look at this blue line. Looking at the x value, it says that it has to be less than the value there. So remembering again, that means I'm looking at the region to the left of the line. We'll need to be a little bit careful if we consider the y value, as we have a negative y value. So looking at that, that's telling us that negative 3y would have to be less than 12. Okay. If negative y is less than something, that means that we'll actually be looking at the region above the line. Remember, if we want it to be more negative, because it has a negative coefficient, we would need a positive y value. You could also consider this by, if we rearrange this equation to put the 4x plus 3y, you may find it useful to make all of your unknown, your variables have positive coefficients, now when we look at this, we can see that y is on the greater side of this inequality, telling us we want the region above. So that just reminds us we must be very, very, very careful. Whenever we have negatives in our equation, it may be that we're on the opposite side of the line to what we think. It's much, much safer just to add the 3 to the other side, look at that, and that tells us that y is on the greater side. So we will be looking at the region above this blue line. Okay, so now let's shade the region that obeys all of these inequalities. I need to be above the parabola, this section here, to the left or below the red line, so that is this region here, and to the left or above the blue dotted line, this region here. The only region which obeys all of those rules is this region. So that is the region that I will shade. That's the answer to this problem. If you're using a GeoGebra file to help you, to avoid the confusion of seeing many shaded areas, the region that solves the problem will be the only unshaded area. Just bear that in mind when you're using a GeoGebra file. It's shading all of the areas which do not satisfy it. It's the unshaded area which satisfies all of our inequalities.